Howdy, this is our homemade laser project. In it, we aim to make a dye laser using a mixture of rhodamine 6G and alcohol. Now, one issue you run into when making a dye laser is that over time, as the dye is excited, it degrades and slowly loses its ability to lace. In order to solve that, we created a pump that slowly circulates fresh mixture in through the cavity. Now we also have a large supply of base liquid that's connected to the pump. This is all powered from the same power supply, just using a voltage regulator to lower the voltage for the pump. Now, for the next component.
Now, one of the most important parts of any lasing setup is the pumping process. In our case, we have this 100-watt LED which emits green light. The pumping process essentially supplies some kind of light into the gain medium in order to excite the atoms in the gain medium, which, as my partner said earlier, is rhodamine 6G. We want to create what is called a population inversion, and this is when there are more atoms in excited energy levels than there are in the ground state. This creates what's called stimulated emissions, which means as the atoms decay back into ground state, they emit photons, which are ultimately going to become our laser beam.
You've heard how the pumping process excites electrons and generates a population inversion, but how do we get from an excited medium to a functioning laser? This is done by containing our gain medium, the dye, in an optical cavity. For visible light lasers, this typically refers to a pair of mirrors on opposite sides of the medium. Now, when excited atoms in our dye undergo spontaneous emission, meaning they randomly release a photon, small amounts of light escape in every direction. But when the portion of the light that's aligned with our cavity hits one of these mirrors, it's reflected back into the medium. This causes what's known as stimulated emission. When a resonant photon hits an excited atom, a new photon is emitted, not randomly as with spontaneous emission, but in the same direction and with the same phase as the initial photon. When this process is repeated over and over again, the number of photons contained inside the cavity builds up. Now, this mirror here is a special kind of mirror called an output coupler. Instead of reflecting all the light that hits it, some is allowed to pass straight through. So as the number of photons bouncing back and forth between these mirrors builds up, a steady beam of coherent light, the laser beam, is emitted.